Hey guys, talk back again. Going over this time it's AMC 12B 2020 number 15. So this is a fun what I call sort of a counting problem or a combinatorics problem. So any problem that usually goes with how many ways are there, that's always sort of what's called a combinatorics problem, which I've always found to be pretty fun. Okay, so this one says there are 10 people standing equally spaced around the circle. Each person knows exactly 3 of the other 9 people. The 2 people standing next to him or her, as well as the person directly across the circle. How many ways are there for the 10 people to split up into 5 pairs so that the members each know each other? Okay, so this one takes you kind of a minute to just understand what they're asking. So they're saying to you, these 10 people, I labeled them A, B, C, D, E, F, G, H, I, J. And each person is friends with both the 2 people standing next to them, as well as the person that's directly across from them. So A is friends with B, J, and F. B is friends with A, C, and G. C is friends with B, C, and H, so on and so forth. And the question asks, how many ways are there to split these 10 people up into pairs so that in each pair, everybody knows each other? So obviously the way you can split the pairs is by either splitting them in such a way where it's 2 people that are directly next to each other or 2 people that are directly across from each other. And those could be possible pairs. So one possibility would be this. So A with B, J with I, H with C, D with E, and F with G, right? So that's one of the possible pairs, but there's many of them, right? And the question's asking how many of them are there? So the way that I based this question was I based it on, well, how many of our pairs are going to be people who are across from each other? Or another way to think of it is how many diameters are we going to make? Like if we're thinking of this like a circle, like this would be a diameter, right? And then so AF being a diameter, then BC being a pair, DE being a pair, HG being a pair, IJ being a pair, right? So that's a 1 diameter case. So I'm going to see, well, how many different cases are there of each number of diameters? Well, how many cases are there with no diameters? So in other words, it's always just the people next to each other. Well, if you kind of think about it, there's really only 2 ways to do that because it's all going to depend on whether you partner A with B, and that's going to sort of generate pairs A, B, C, D, E, F, G, H, I, J, or do you partner A with J, in which case you're going to have make AJ, B, C, D, E, F, G, and H, I. So there's really only 2 ways to do it to make it so that there would be no diameters, right? So we have 2 possibilities for that situation, right? What if we make 1 diameter? Well, I kind of already showed one example, which would be what we'll just make AF a pair, and then you're gonna have D with E, B with C, J with I, and H with G, right? But that's just one of the possible diameters. If you notice, there's basically 5 possible diameters: AF, BG, CH, DI, and EJ. So that means that there's 5 different cases containing 1 possible diameter. Now, this next one's a little weird because you say, well, how many cases are there where there be 2 diameters? The answer actually is none. And this could take a few minutes to really understand why there's no possibilities with 2 diameters. The main reason being that if you use 2 diameters, that's going to leave you with 6 people. The only way you can have it to be 6 people where there would be even numbers so that they could partner up would be if you split it by 4 and 2. But you'll notice that there's actually no possible way to do that because why is it not possible? Because if you pick, let's say you pick B to be like a diameter with G, and then you're going to have to leave a space of 2, and then you're going to have E partner with 1, 2, 3, 4, 5 J, right? 2, 3, 4. Wait, sorry. So B with J, and E with 1, 2, 3, 4, 5. So E with J, right? But you're gonna notice that that's not gonna possibly leave you with, like it'll leave you 2 here and then 1 and 1. So it's just not possible to make it so that you're gonna have exactly 2 pairs, right? So and you can convince yourself why that's the case. There's no way to do it with exactly 2 pairs, right? Okay, so that case has 0 possibilities, right? What about 3 diameters? Well, that is possible. Basically, you just pick any 3 in a row. E with A with F, B with G, and C with H, right? And then that's going to leave you IJ to be a partner and DE to be a partner, right? And you'll notice that it's only possible if the 3 are in a row. Because if the 3 are not in a row, you're going to leave yourself with just 1 person by themselves, which obviously we'll have no partner. So the question just becomes, well, how many of these sort of 3 in a rows can we have? Well, base it on which one is to the furthest left. In this case, I'm making A my, sort of first diameter that's farthest to the left, right? Well, if you think about it, when will we get back to that? We'll get back to that when we make F the one furthest to the left, because then that just corresponds to this exact same situation. So that means the ones that could be furthest to the left would be A, B, C, D, or E. So there are 5 possibilities with 3 diameters, right? And again, you can sort of convince yourself of that, right? How many ways with 4 diameters? 0, because 4 diameters is always going to leave you with 1 and 1, right? Because there's always going to be a partnership that's not connected with the diameter, but then they don't have any partners. So you're going to have these just ones by themselves that can't have partners. So 0. And then 5 is just every diameter pair, which obviously there's only one way to do that. So, which I drew that really bad, but right. So, and again, you can sort of convince yourself why this is true. Oh, I'm sorry. It's supposed to be a 1, not a 5. Sorry. 1, right? So now that we've done that, how many possibilities do we have total? 2 plus 5 plus 5 plus 1 is 13. So there are 13 possible ways to make this happen. That's the answer. So again, I would love to see if anybody can come up with a better solution, more interesting solution. That's what I think is really fun. And hope you enjoyed. See you next time.